So this is part 4 of the session on continuity and differentiability, and also the last part in the section on continuity and differentiability. Here we will be introducing differentiation and also the chain rule. So we just go through the product rule of two functions, that is derivative of two functions u and v is u into derivative of v plus v into derivative of u. Coming to question 1, show that the function f is continuous at x equal to 1 for all values of a. Find the right and left hand derivatives at x equal to 1. Hence find the condition for the existence of the derivative at x equal to 1. Fx is ax squared plus 1 when x greater than or equal to 1, equal to x plus a when x is less than 1. So limit as extending to 1 to the left of fx will be limit as extending to 1. 1 to the left means x less than 1. So it will be limit as extending to 1 of x plus a, that is 1 plus a. And limit as extending to 1 to the right of fx will be 1 to the right means fx is ax squared plus 1. So it will be limit as extending to 1 of ax squared plus 1, which is 1 plus a. And you can see that f of 1 will be equal to, f of 1 will be same as this, so that will be a plus 1. So we have left hand limit equal to right hand limit equal to f of 1. So we can say that therefore f is continuous at x equal to 1 for all values of a. Now right hand derivative of f at 1 is defined as limit as h tending to 0 to the right f of 1 plus h minus f of 1 by h. H tends to 0 to the right means 1 plus h is greater than 1. So f of 1 plus h will be a into 1 plus h the whole square plus 1 minus f of 1 we have seen is already a plus 1. So when I expand this I get a into 1 plus 2h plus h squared plus 1 minus a plus 1. So we can see that the a and the 1 cancels and you get limit as h tending to 0 to ah plus ah squared by h. That will be limit as h tending to 0 to a plus ah, that is 2a. This is the right hand derivative of f at 1. The left hand derivative of f at 1 will be limit as h tending to 0 to the left f of 1 plus h minus f of 1 by h. H tends to 0 to the left, so f of 1 plus h will be less than 1. So f of 1 plus h will be 1 plus h plus a minus a plus 1. So the a and 1 gets cancelled. So you get limit as h tending to 0 of h by h equal to 1. So the left hand derivative of f at 1 is 1. So the right hand derivative of f at 1 is 2a, left hand derivative of f of 1 is 1, and you are given that the derivative of f exists at x equal to 1. So right hand derivative of f at 1 will be equal to the left hand derivative of f of 1 or 2a equal to 1. That means a equal to half. So this is what we have to find out, the value of a. Now we come to derivatives of trigonometric functions. Before that, some notations. F dash x you denote by d by dx. This is called d dx or derivative with respect to y. D dy is derivative. D dx is derivative with respect to x. D dy is derivative with respect to y. Now derivative of sin x is cos x. Derivative of cos x is minus sin x. D dx of tan x is secant squared x. This we had already learnt before. In d dx of x raised to n is n x raised to n minus 1, where n is any integer. Derivative of cot x is minus cos x squared x. D dx of sec x is sec x tan x. And derivative of cosec x is minus cosec x cot x. So you have to learn all this. There is no shortcut. Coming to problems, differentiate with respect to x. 5 tan x minus 3 sin x plus 4x raised to 3 by 2. So whatever we have to differentiate, we call it y. So dy by dx equal to 5 into derivative of tan x is secant squared x minus 3 into derivative of sin x is cos x plus 4 into derivative of x raised to 3 by 2 is 3 by 2 x raised to 3 by 2 minus 1, that is half. So that is 5 secant squared x minus 3 cos x plus 6 x raised to half. Coming to question 3, differentiate 1 minus 2 tan x into 5 plus 4 sin x with respect to x. Now either you can multiply and you get 4 terms, or you can use the product rule. So what does the product rule say? It is 1 minus 2 tan x into derivative of the second function plus the second function into derivative of the first function. That is 1 minus 2 tan x, derivative of 3 is 0. So 0 plus 4 into derivative of sin x is cos x, plus 3 plus 4 sin x, derivative of 1 is 0, minus 2 derivative of tan x is secant squared x. So we just rearrange it and write it as 4 into 1 minus 2 tan x into cos x, minus 2 into 3 plus 4 sin x into secant squared x. Question 4, this is actually question 4. Differentiate sec x minus 1 by sec x plus 1. Now we use the quotient rule. So what is the quotient rule? You have u by v dash. If you have two functions, derivative of the two functions will be, denominator is v squared. So I have v squared here. Then I have v u dash minus u v dash. So this is sec x plus 1 into derivative of sec x minus 1, that is sec x tan x, minus u is sec x minus 1 into derivative of sec x plus 1 is sec x tan x. So when you open the bracket, I get secant squared x tan x plus sec x tan x minus secant squared x tan x plus sec x tan x. So you can see that the secant squared x tan x gets cancelled. Sec x tan x plus sec x tan x will give you 2 sec x tan x by sec x plus 1 the whole squared. You can simplify it. You can write sec as 1 by cos, tan as sin by cos. So the cos squared x gets cancelled and you get 2 sin x by 1 plus cos x the whole squared. Next question, differentiate root sec x plus tan x by sec x minus tan x. Now here we can actually rationalize it before we simplify it, because it becomes complicated otherwise. So multiply and divide by the conjugate, that is sec x plus tan x. Note this step. So it becomes root of sec x plus tan x the whole squared by, this is a minus b into a plus b, which is a squared minus b squared. So I get secant squared x minus tan squared x. Secant squared x minus tan squared x is 1. And root of sec x plus tan x the whole squared is sec x plus tan x. So your y is actually sec x plus tan x. And dy by dx will be derivative of sec x is sec x tan x plus derivative of tan x is secant squared x. So see how the complicated function reduced to a simpler form. Next question, if y equal to 2 minus 3 cos x by sin x, find dy by dx at x equal to pi by 4. I think I've got the numbering of the questions wrong, but it doesn't matter. So I can simplify this to 2 by sin x minus 3 cos x by sin x is cot x, that is 2 cosec x minus 3 cot x. So dy by dx will be 2 into derivative of cosec x is minus cosec x cot x, derivative of cot x is minus, so minus minus will give you plus, you have a 3 here, cosec squared x. So this is your dy by dx, you need to calculate dy by dx at x equal to pi by 4. So if I substitute x equal to pi by 4, I get minus 2 cosec pi by 4 cot pi by 4 plus 3 cosec squared pi by 4. Sin pi by 4 is 1 by root 2. So cosec pi by 4 is root 2, cot pi by 4 is 1 plus 3 into 2, because cosec pi by 4 is root 2, cosec squared pi by 4 is 2. So I get 6 minus 2 root 2, which is your answer. Now we have the chain rule, which is extremely important, and this says that if y is a function of u and u is a function of g, then dy by dx is dy by du into du by dx. We'll learn this more when we apply to problems. One more formula to remember, that is d dx of mod x is x by mod x provided x not equal to 0. So coming to the next question, fx is root 4 minus x squared, where x belongs to the open interval minus 2 to 2, find f dash x. So supposing I call this as u. So f dash x will be what? 1 by 2 root u. What is f dash x? 1 by 2 root x. So f dash u will be 1 by 2 root u. Now substitute back for u, that is root 4 minus x squared, into d dx of u, that is 4 minus x squared. That will be 1 by 2 root 4 minus x squared into minus 2x, which is what we have here. So this is minus x by root 4 minus x squared. Next question, differentiate sine cubed x plus cos raised to 6x. So we can write this as sin x the whole cube plus cos x the whole raised to 6, and I call this as y. Now I can call sin x as u and cos x as v. So derivative of u cubed is 3u squared into du by dx, that is 3 sin x the whole squared into d dx of sin x. Derivative of v raised to 6 is 6v raised to 5 into dv by dx, that is 6 into cos x raised to 5 into d dx of cos x. Instead of x, whatever you have, apply the formula and then multiply by derivative of that. That's the logic we use. So that is 3 sin squared x, derivative of sin x is cos x, plus 6 cos raised to 5x, derivative of cos x is minus sin x. So I can write it as 3 sin squared x cos x minus 6 cos raised to 5x sin x. Next question, differentiate cos root x with respect to x. So basically I'm finding d dx of cos root x. So now I will call cos root x as u. So what is derivative of cos u? Minus sin u into du by dx. So that is minus sin root x into d dx of root x. And d dx of root x is 1 by 2 root x. So this is minus sin root x into 1 by 2 root x. You can simplify and write it as minus 1 by 2 root x sin root x. Next, differentiate cos of tan root x plus 1 with respect to x. Now here again you will call this as u, tan root x plus 1 you call as u. So dy by dx will be derivative of cos u is minus sin u. So it will be minus sin tan root x plus 1 into d dx of tan root x plus 1. That is minus sin tan root x plus 1. Now tan root x plus 1 you can call as a v. So root x plus 1 I will call as v. So derivative of tan x is secant squared x. So it will be secant squared v here. That is secant squared root x plus 1. And instead of x, what do I have? I have root x plus 1. So into d dx of root x plus 1. That will be minus sin tan root x plus 1 into secant squared root x plus 1. d dx of root x plus 1 is 1 by 2 root x plus 1. So that is what we have here into d dx of x plus 1, because if I call x plus 1 as a w, you will get d dx of x plus 1, and when you simplify, derivative of x plus 1 is 1. So when you simplify, you get minus 1 by 2 root x plus 1 sine of tan root x plus 1 into secant squared root x plus 1. That is our answer. Question 9. Fx equal to x raised to 100 by 100 plus x raised to 99 by 99 plus x raised to 98 by 98 up to, this is actually plus x plus 1. So you have to show that f dash 1 is 100 into f dash 0. So this is your fx. F dash x will be 100 x raised to 99, because I am making use of the fact that d dx of x raised to n equal to n x raised to n minus 1, where n is an integer. So this is 100 x raised to 99 by 100 plus 99 x raised to 98 by 99 plus 98 x raised to 97 by 98 plus derivative of x is 1, derivative of 1 is 0. So 100, 99, 98 all get cancelled, and you get x raised to 99 plus x raised to 98 plus x raised to 97 up to 1. That is, f dash 1 will be up to x raised to 0. So you are counting from 0, 1, 2 up to 99 times, that is 100. So f dash 1 is 100, and f dash 0 you can see if you substitute 0 you get 1. So we have proved that f dash 1 is 100 into f dash 0 substituting which is what we have to prove. Next question, find the derivative with respect to x of modulus of 2x squared minus 3. So I'll use this property that which I had stated before, that d dx of mod x equal to x by mod x provided x not equal to 0. So this is 2x squared minus 3 if I call this as u. So this is u by mod u into d dx of u. So it is 2x squared minus 3 by mod 2x squared minus 3 into d dx of 2x squared minus 3, which is 4x. So this is your answer. Practice makes you perfect, so you have to take a pen and paper and practice each slide, each step along with me. Thank you.